The phone application suggests that the sampled fern is Blechnum orientale. Is it? Let's see. Well, Blechnum orientale is from the family Blechnaceae, which is characterized by unique sorrel morphology. That is, the sorus is arranged in a continuous line near the midrib, as seen in the sample. Further evidence that the fern seen is from the family Blechnaceae comes from the front's reddish color when young, rachises grooved at axially, stipe with more than 2 vascular bundles, and spores monolete. The phone application's identification, at least at family level, is thus well supported. I then compared the sample to the genera used in one of the many genus level treatments of Blechnaceae, where there are 7 genera, which are Blechnum, Brainiae, Satleria, Salpiclina, Stenoclina, Blechnum, and Woodwardia. Of these 7 genera, Salpiclina has a climbing habit using twining rachises, rhizome long creeping, and frond bipinnate, unlike the sampled fern, and thus Salpiclina is not the sampled fern's genus. Stenoclina also climbs, but with scandent rhizomes, and has ex-induciate sori, which may cover the abaxial surfaces of the pinnae. These characters exclude Stenoclina as the identity of the sample. Brainiae, like Stenoclina, and unlike the sample, has ex-induciate sori. Brainiae also has an arborescent rhizome. These characters suggest the sample is not from the genus Brainiae. While Woodwardia is induciate like the sample, Woodwardia has chain-like sori, that is sori that follow the areolar veins but are interrupted. Woodwardia also has veins anastomosing to form a series of areoles along the costa and costule. Since the sample has continuous sori and free veins, the sample is not from the genus Woodwardia. Blechnum has pinnae articulate, pinnae margins serrate, and rhizome long creeping, differentiating Blechnum from the sample. The sample is also not from the genus Satleria, which has fronds pinnate pinnatified to bipinnate, as opposed to the one pinnate fronds of the sample. Additionally, Satleria is confined to the Hawaiian Islands, while I am looking at ferns around where I live in Malaysia. So that leaves the genus Blechnum, and the sample shows characteristics found in Blechnum, such as rhizome erect to ascending with scales, fronds monomorphic, blades with many pinnae, veins free, sometimes once forked, sori linear along the costa, occupying a narrow region of the pinnae undersurface, the U-black knot condition, inducia present, and reflex that is bent or turned backwards. So the genus level identification as Blechnum suggested by the phone application is correct when Blechnaceae is divided into 7 genera. However, under a different classification scheme, there have been alternate names given to the species. For example, the Blechnum species that have been found in Peninsular Malaysia are Blechnum finlaysonianum or Blechnopsis finlaysoniana, Blechnum fraseri or Diploblechnum fraseri, Blechnum orientale or Blechnopsis orientalis, Blechnum pattersoni or Austroblechnum pattersoni, Blechnum vestitum or Parablechnum vestitum, and Blechnum melanocolon or Austroblechnum melanocolon. I quickly eliminated those species distinctly different from the sample, which were Blechnum fraseri, Blechnum pattersoni, Blechnum vestitum, and Blechnum melanocolon. Blechnum fraseri or Diploblechnum fraseri was eliminated as the sample's identity based on its 2 pinnatified laminae and rachises with a jagged wing, unlike the sample's 1 pinnate laminae and absence of wings on the rachises. Blechnum pattersoni or Austroblechnum pattersoni was eliminated as the species identity because sterile lamina are either undivided or have only 1 to 4 pairs of pinnae with a continuous wing of lamina extending down the rachis below the basal pinnae, and the fertile fronds have 1 to 2 pairs of pinnae. The sampled fern's fronds differed as it is monomorphic with many pinnae. Blechnum vestitum or Parablechnum vestitum was eliminated as the species identity as its fertile pinnae are very narrow, scales broadly deltoid, and pinnae and rachises densely and usually persistently scaly. The sample, however, has monomorphic pinnae, scales elliptical or linear, and pinnae not scaly. Blechnum melanocolon or Austroblechnum melanocolon was eliminated as the species identity as it has distinct fertile pinnae, much narrower than the sterile ones, and the sori covering the abaxial pinnae surface, unlike the sample's monomorphic pinnae and sori only near the midrib of the pinnae. Though Blechnum finlaysonianum or Blechnopsis finlaysoniana is not very different from the sample, there are differences, such as Blechnum finlaysonianum's sori rarely enlarged to overlap or cover the costa, pinnae apices abruptly narrowed to form an acuminate apex, and fronds of juvenile plants entire or lobed. Thus, the sample was not Blechnopsis finlaysoniana. The sample was most probably Blechnum orientale or Blechnopsis orientalis. Blechnopsis orientalis has terrestrial habit, rhizome thick, ascending or sub-erect, covered with scales, scales linear, narrowing towards apex, dark brown, stipe stout at axially sulcate, strenuous or purplish, scaly at base and sometimes hairy. Fronds monomorphic, juvenile fronds pinatified, lower lobes have rounded to obtuse tips, mature fronds laminar, ovate to deltate, with many pairs of alternate pinnae, apices subconform. Lower pinnae contracted to auricles, upper ones oblique, linear or narrowly elliptic, tapered to an acuminate apex. Pinnae bases truncate or cuneate and sessile to petiolate towards the laminar base, and increasingly adnate and decurrent towards laminar apex. Pinnae margins entire. Veins simple, maybe once forked near costa. Sori narrow, continuous along costa, protected by elongate inducer that opens towards the costa. Spores monolete. To learn more about the Blechnaceae ferns, do look up the references provided. To be introduced to other plants, do look up the channel and subscribe to get further uploads. Thank you for your support.